Hello viewers, myself Dr. Mahantesh K, Associate Professor, Department of ECE, SJB Institute of Technology. Welcome you to this online pre-recorded video sessions of electromagnetic waves, class 15, that is module 2, class 7, as per VTU syllabus. In this video, we will be discussing about conductors and dielectrics. In our previous videos, we have learned about work done, force expended in moving a charged particle against the electric field, and potential gradients, and dipole concepts in my previous videos. So we shall try to describe what you mean by a current and current density along with convection current. So electric charges in motion constitute a current. So it is a rate of change of charges with respect to time gives current given by I is equal to dq by dt. Hence, current is defined as the motion of positive charges, although conduction in metals takes place through the motion of electrons. So the current density J is defined as measured in amperes per square meters. So what is current density? Current density is the total current over total surface area. The increment of current delta I crossing an incremental surface delta S normal to the current density is given by delta I Jn delta S, where J is equal to current density. If the current density is not perpendicular to the surface, then delta I is equal to J dot delta S. Through integration, the total current is obtained as I is equal to surface integral of J dot ds. So this is a very important equation which you need to remember in order to calculate the total current when the given current density with respect to the surface is given in terms of amperes. So current density may be related to the velocity of volume charge density. Just imagine a very small volume charge with the volume charge density rho v is given as is moving in the direction delta x. So the initial position of this small volume was at the origin. Now we could see this is moved with respect to delta x in delta x direction. An element of charge delta q can be given as in terms of volume charge density and the volume in terms of delta S into delta L, where delta Q is equal to rho V into delta V. Delta V can be represented in terms of surface and length as delta S into delta L, moving along the x-axis. In the time interval delta T, the element of charge has moved to a distance delta X. Therefore, I can give an equation as delta I is equal to delta Q by delta T. Substituting the values of delta Q, I would get rho v delta S into delta X by delta T. So delta L is equal to delta X. So I found delta X by delta T, which is nothing but a velocity. Rate of change of displacement with respect to time, call it as velocity. Rewriting the equation, I could write delta I is equal to rho v delta S into Vx. So where Vx is the velocity in the direction X. So in terms of current density, we can find J is equal to rho V into Vx or rho V into V in general. Therefore, current density is equal to the product of volume charge density into velocity. And this is called as convection current density. So charge in motion constitute a current. We name it here as a convection current due to the volume charge moving with some velocity produces convection current density. We shall now discuss a continuity of current concept. Continuity of current concept is based on the principle of conservation of charges. We say charges can neither be created nor be destroyed, but can be converted from one form to another form. We know that I is equal to J dot ds due to the continuity equation in closed surface. An outward flow of positive charges shall be balanced by a decrease of positive charges within the closed surface and can be related to the equation I equal to surface integral j dot ds, which is equal to minus dqi by dt. So the integral form of the continuity equation. And the differential form of the continuity equation can be given as. So now I am going to convert this surface integral to a volume integral using divergence concept. Surface integral JDS is equal to volume integral of del dot G, del dot J dV. Now we shall try to represent this del dot J dV in terms of, we will equate it to Q minus dq by dt, where Q is equal to volume integral rho v dV. Therefore, I can rewrite the equation. The derivative becomes a partial derivative when it moves inside the volume integral. Therefore, the volume integral of del dot j dv is equal to volume integral of minus dou rho v by dou t dv. Therefore, equating the integral components, I can write del dot j is equal to minus dou rho v by dou t. This is the differential form of the continuity equation. So, del dot J, divergence of current density, is equal to the rate of change, the decremental rate of change of volume charge density with respect to time. Let us solve a simple problem. If the current density is given, total outward current at instant t is equal to 1 second, I can find I is equal to the total outward current at time instant t is equal to 1 second and r is equal to 6 meters. I can find total current is equal to 27.74. So how to find the volume charge density using the continuity of current equation delta J is equal to minus dou rho v by dou t. Therefore, rho v is equal to 1 over r square e power minus t plus constant. Therefore, finally, rho v is equal to 1 over r square e power minus t coulomb per meter cube. And we can define velocity is equal to j by rho v is equal to r meters per second. Thank you for watching this video. Hope you understood the concept of continuity of current and current density with respect to the conductors.